Lesson 7a, Properties of Rational Exponents and Evaluating Nth Roots, is a lesson where we're going to be looking at the difference between radical form and rational exponential form, rational meaning fractions. So the main thing that you need to acknowledge are these different forms that you see here. There's 4 of them. Here you have the b root of x to the a power. This b represents your index or your nth root. A lot of times you don't see any number written there because it's an understood 2, which represents a square root. But if it's any number other than 2, then you'll have to see the number, that index, written there. And so you can go between radical form that you see here. It doesn't matter if you want to deal with the radical part and then the exponent, or raise the exponential and then do the radical. I usually try to make the value smaller by taking the radical first and then raise it to the power. And then that's the same thing as writing it in rational exponential form. And when you convert between radical form to rational exponential form, the exponent that belongs to the variable here is your numerator, and the index, which is on the outside of the radicand, is your denominator. And again, it doesn't matter if you want to deal with that part first and then do the exponent, or just do them all at once. So if we were just, we're not evaluating right now, if we were just going to rewrite these guys, this right here, remember the denominator becomes the index and the numerator is the exponent, would just be the square root of 25 cubed. It doesn't matter if you want to put the 3 here or the 3 on the outside. Now, because I know the square root of 25, I'm going to go ahead and do that first. Make the number smaller, and then cube it. So then my answer would be 5 cubed, or 125. But again, the emphasis here is not on you getting the answer, it's on you rewriting it between exponential form to radical form. So here what we're talking about is 16 to the 9 over 4 power. So that's going to be the 4th root of 16 to the 9th power. Different than I wrote example 1, but it's the same thing. I just wanted to show you. Here I just put everything under the radical. It doesn't matter if you put that 9 under the radical or to the outside. So you take the 4th root of 16, which is 2, and raise it to the 9th power. And you would probably use a calculator to do that. Here we're talking about the cubic root of 27 squared. Put that 2 inside or outside, it's up to you. Now if you see it in radical form, that's going to be 2 to the 2 over 3 power. And this is going to be 16 to the 6 over 4 power. Now you shouldn't leave it as 6 over 4. That's the same thing as 16. They're just fractions, so you would want to reduce that to the 3/2 power. Okay, and then this would be negative 125 to the 4/3 power. Now the way I have it right now is actually incorrect, because order of operations says that let's do the exponent and then we'll worry about that. That negative needs to be raised to the 4/3 power as well. So you want to make sure that anything that goes to the power gets put in parentheses. Alright, if you see negative exponents, it's just putting it 1 over the same thing that has a negative exponent but to a positive. If it's already in the denominator, then you can bring it up to the numerator. So if you had like 1 over x to the negative 7th. You move its location, so if it's in the denominator and you bring it up to the numerator, and then you would change the sign to a positive. So this little rule right here works either way. So this would be the same thing as 1 over 81 to the 3/4 power. And this would be 1 over 27 to the 2/3 power. let's actually look at doing some of these. I did some of these already. So this is the square root, because that 2 would go there. You don't have to write the 2, of 25 cubed. So that's going to be 125. This is the 4th root of 16 to the negative 9 power. The 4th root of 16 is 2 to the negative 9 power, means 1 over 2 to the positive 9 power. This is the cubic root of 27, which the cubic root of 27 is 3 squared would give us 9. Okay, this is the cubic root of 4, and that could be also 4 to the 1/3. The 4th root of 16 is 2 to the 6th power. The cubic root of negative 125 is negative 5, and that's to the 4th power. So that's just a couple of examples that we actually would work out or simplify. You want to make sure that you use all your rules of exponents that you've already learned. This is product, so same base, keep the base, add the exponents. Power, you see the base written once, you're multiplying the exponents, or you're raising that, so you would just multiply them. Negative exponents. Quotient, you subtract. Here, everything being raised to the power gets that power, you can break it up. But if we apply those rules to radicals as well, this just says that every every term on the inside of that radical belongs to there, so you can break it apart. Quotient's the same rule, but you had this little disclaimer here that your denominator can't equal 0. And you need to know that indexes cancel out exponents. So an nth root of something to the nth power does cancel out. If your nth root is an odd root, it'll be whatever you see. But if it's an even root, like a square root or a 4th root, you need to make sure that it's the absolute value, because you're not sure if the negative 2 times a negative 2 was a positive 4, or a positive 2 times a positive 2 was the positive 4. So if we do the absolute value, that covers all the bases for that. So let's put some of those rules to use here. The square root of 72. What we're going to do is, since 72 is not a perfect square, we're going to break it up into the highest perfect square, which is 36. That can go into 72. And then I'm going to take the square root of 36. This was one of our rules. You can break them up into their own radicals. And the square root of 36 is 6. Square root of 2. Okay? So 6th roots are a little bit harder. I mean, people don't really no one asked you to memorize your 6th roots before. So what is a 6th root that can go into 256? Well, 2 to the 6th power is 64. That's going to leave you with 4 more. And the 6th root of 64 is 2. So what we have here is 2 6th root of 4. Here's that quotient rule example here. So this is the cubic root of x to the 6th. That's a 6. Over the cubic root of y to the 7th. And then what we're going to do is we're going to pull out as many x to the 6 as we can out of here. So 6 over 3 is 2, so that just simplifies to x squared. You don't even need a radical anymore. We can pull out 2 y's, but that's going to leave us with 1 more. So you're going to have times the cubic root of, can't really see that, y to the 1st. Alright, cubic root that can go into 48. is 2. So we have the cubic root of 8 times 6, and a cubic root that can go into 750 is 125. So we're going to do 125 times 6. So we have 5 times the cubic root of 8 times the cubic root of 6. We're using those properties that are on the page before this one, minus the cubic root of 125 times the cubic root of 6. And so you're going to simplify the ones that you can. You have 5 times the cubic root of 8. Cubic root of 8 is 2, so that's going to give us 10 cubic root of 6 minus 5 cubic root of 6. And since our radicals are the same, we can actually put those together, and that's going to leave us with 5 cubic root of 6. You treat those as like terms, and you just work with the coefficients. All right, here we're working with square roots, so you want to pull out as many as you can. You never want to leave an exponent under a radical that's larger than its index. So we have that x. The square root of 9 is 3. So we're going to pull that x cubed into an x squared and an x. And that x to the 5th we're going to separate into an x to the 4th and an x. Okay, so let me switch colors here. This can simplify and this can simplify. And so what we get there is 3. We already have an x, and this is going to give us another x, so that's x squared, leaving us with one more x under the radical. This is x squared, so that's minus 2x squared with an x under the radical. And so 3x squared square root of x minus 2x squared square root of x is 1x squared square root of x. All right, on example 6, you might want to simplify before we start worrying about the radicals. Is there anything that can go into 20 and 9? No. Let's work with our x cubed and our x's. And so since it's the same base, we're going to simplify that. This will take out one of those, so we'll have x squared on the top. And then we have y squared here. And then on the bottom, you're going to have the square root of 9. The x has been simplified, and we still have z cubed would be z squared times z. And this 20 would actually be 4 times 5. You want to pull out the largest. Okay, so the square root of 4 comes out. The square root of x squared comes out. The square root of y squared comes out. Those are actually supposed to be in absolute value bars. We talked about that. And so we're still left with the square root of 5 under the radical. And then we have 3 absolute value of z over the square root of z. And that would be as simplified as we can get it. Now don't forget about your graphing calculator. You can put numerical things in your calculator. Let me get to do what I did here, and this is the 5th root of 32. You first type in your 5 that you see here. Okay, you first type in the 5, and then you're going to type in your math key. Your math key is right here, and when you hit that math key right there, this menu is going to appear, and so it'll allow you to do a cubic root, but then if you want any root, you would just choose number 5, which is what we did. So I did 5 math 5, and then I wanted 32, and I hit enter. Now if you don't feel like dealing with the math menu and trying to do it as a radical, keep in mind you can always just convert your radical form into exponential form and just do 32 to the 1/5 power. Notice you get the same answer. So your graphing calculator will definitely help you with numerical simplification. It can't do the variable ones. So those are the ones where you're really going to have to know all your rules.